Okay, so in 6.4, we're going to move on and look at logarithmic functions. One thing to keep in mind that the logarithmic function is the inverse of the exponential function. So, your exponential function right here, remember we had this the other day in 6.3. It looks like this. Well, it really doesn't matter what variables we use here because I'm going to kind of rewrite things as we do down here in this definition. Just the important thing is your exponent. You have an exponent as a variable, okay? And I'm doing this to help you understand how to transition from what's a logarithm to the exponential form. So even though the exponential function looks like this, we can still identify a, x, and y just writing it in a different form. All right, so we have two types of logarithms we're going to be looking at. The common logarithm and the natural logarithm. Now, the differences are the base, okay? So when we look at the common logarithm, whole numbers for the base, and we look at the natural logarithm, e is the base, okay? The only difference on your calculator, you've got buttons. You've got the common log and the natural log. And as you can see above your calculator, and most 90-some% of your calculators are going to be set up this way. Not all of them, but most of them. You can see the natural log and it has E above it. That's, the inverses. The common log, this one has just base 10 because you can't physically put all the bases, all right? You got to think about it. So they've just defaulted your calculator to base 10. Now, when bases are 2, 3, 4, 5, 6, etc., there's other ways to work with it, and we'll get to that later. But just right now, know that the default base on your calculator is 10. All right, so here's your definition. So you have a logarithm, and if you're given a logarithm, your base is a, x is what I call the number, and then equals to y, because the answer to a logarithm is an exponent, okay? We can also say if we have this, then this is true here, where as an exponential equation, your number is your base to the exponent, all right? If you can do that, if you can transition from here to here and backwards, then you won't have much trouble with these. The problem I see is students think that this is an exponent. X is not an exponent. This is logarithmic form, okay? This is a logarithm. Y is the exponent in a logarithm. That's a subscript. If you don't know what a subscript is, it is a number that is kind of like below the natural line on your paper. It's a subscript. So you can't think that this is a to the x power equals y. Not true. Can't stress that enough. All right, so the way we read this is log base a of x is y. Again, a is the base, y is the exponent, x is the number. So when you transfer from one form to the other, just imagine replacing the base with the base, the exponent with the exponent, and the number with the number. Don't overcomplicate it, okay? Just don't overcomplicate it. All right, so remember, when we evaluate a logarithm, we get an exponent as an answer. Now, one thing to remember, in a common logarithm, if there is no subscript given, then we assume the base is 10. So, for example, if I'm given an exponential equation, 10 to the fourth power is 10,000. As a logarithm, I can say the log of 10,000 is 4. So try that on your calculator. Just do log 10,000. Now, on this calculator, I have to enter the 10,000 first and then press log. But a lot of other calculators, you just type log 10,000, hit equals, and you should get 4. Because, again, 10 to the 4th power is 10,000. So we don't write the 10 in here, but if you want to, go ahead. Okay, it might make you feel better. But see how that is below the line here? This is not 10 to the 10,000 power. All right, next one. If 5 cubed is 125, then log base 5 of 125 is 3. Always remember, this is your base. This is your exponent. This is the number. Base, exponent, number. And so we can finish these out. Log base 6 of 36 is 2. Always remember, in a logarithm, your exponent's on the other side of the equal sign, and I think that will make it easier for you to get the rest of them. All right, so this next one here, if I translate it to a logarithm, I've got log base 10 of 150 equals x. So right there, I'm solving for the exponent. That's why we have logarithms, so we can solve when the exponent is unknown in an exponential function. So you can just do log 150 in your calculator, and you get 2.18 roughly. So we've solved an equation. Okay, same thing here. Log base 10 of 1300 equals x. Again, base is 10. 1300 is the number. X is the exponent. Anytime you change from one form to the other, you should end up with something you can put in your calculator. I cannot put 10 to the x in my calculator, but I can put log 1300 into my calculator. So I go 1300, and I hit the log, and I get 3.11. So in this case, x is 3.11. Okay. So it's just a matter of, this is a practice of how to change from one form to the other. So if we're given a logarithm, again, log of 100 is 2 because 10 squared is 100. Okay, those are just translating from one form to the other. Log of 1,000 is 3 because 10 cubed is 1,000. Log base 4 of 16 is 2 because 4 squared is 16. So if I translate this one here, remember that 3 is the base, negative 2 is the exponent, 1/9 is the number. Now, like I said, don't overcomplicate it. You've got a definition right up here. Just replace A with A, X with X, Y with Y. Don't make it harder than it is. Log of 1 is 0. Well, my base, again, is 10 because we don't write it, so we assume it's 10. The exponent is 0. The number is 1. Next one here, we do not know the number. So if I do not know the number, the way I can find the number is I can say, oh, 10 to the 2.5 power is x. Because my base is 10, that's my exponent. That's what's not known. So then I just put it into my calculator, and I get 316.23. So that's how you solve logarithmic equations. Okay, that's why on the test, if you don't know how to do this, there's not much partial credit to give you because they're pretty much two-step problems for the most part. This next one here might be a little three-step problem because I have a 2x. So my base is still 10. My exponent is 1.4. My number is 2x. Just know what goes where. Then I take 10 to the 1.4 power, and I get 25.12. So 2x is 25.12 divided by 2. And then x is 12.56. Okay, so That's pretty much it. Now, equations can get a little more difficult, more steps involved, and we do graph and do domain, but as far as, solving equations, there's not much more to do, but you've got to know how to change forms. I mean, you just got to know how to do it. If you don't, then it's going to be tough. All right, the other logarithm is the natural logarithm. So in this case, your ln, not I, ln, which is what we see on your calculator right here. If it's in this format, then our base is e. So nothing changes. The only thing that changes is our base. So e is the base, y is the exponent, x is the number. So the only difference between the natural log and the common log is the base. That's all. The form change still stays the same. If I say e to the 1.5 power is 4.48, then if I put natural log of 4.48 in my calculator, I should get 1.5. Okay, 1.4996, that's 1.5. If e to the 2.3 is 10, then natural log of 10 is 2.3. So looking here, I do not know my exponent. So if I do not know my exponent, then I say, oh, natural log of 25 is x. Change it to a natural logarithm. We don't write the base but it's e. Goes right down here. Put in 25 ln in my calculator and I get 3.22. It doesn't matter how you write it. X is 3.22 or 3.22 is x. The difference with here is we are straight evaluating. Here we don't know, so we have to find out what x is. So ln of 25 is 3.22. That's kind of what we're saying there. For this one here, change it to a logarithm. ln of 50 is 2x. Now I'm going to find out what the natural log of 50 is. So 3.91 is 2x. Divide by 2 to get 1.96. Okay, so x is 1.96. And going the other way, same thing we did earlier. If I start with a logarithm and I need to change it to an exponential form, again, I just need to know my base, my exponent, my number. Exponents, right side. Number here, base is e. So if I have the natural log of 75 is 4.3, my base to my exponent is my number. Same thing here. E is my base. My exponent is negative 0.69, and that should give me 0.5. You can check it on your calculator. That's provided you know how to work your calculator. But e to the 4.3, again, we're rounding. So, it's going to be close, but that's how you can always check it. Now, down here, well, I don't know x. But again, that's my number. But I do know my base, I do know my exponent, and that's how I find my x. So 2.4, so I get about 11.02. That's how I'm solving. Same thing here. I know my base, I know my exponent, and I can find my number. So 1.6 negative, second e, and I get about 0.2. Okay, so the first thing you've got to do is identify your base, your exponent, and your number. Change from one form to the other. Do not change from a logarithm to a logarithm. Don't work that way. You change from a logarithm to an exponential, or an exponential to a logarithm, and then proceed. So, if we are solving logarithmic equations, it's pretty much just what we've been doing here. We've solved logarithmic equations. The first thing you must do is make sure you have the log to whatever after it isolated. Rewrite as an exponential equation. Solve for the unknown. Okay. So if I start off right here, I have it isolated. So I change to an exponential equation. And I'm just writing, you can write it one of two ways. My base is 10. Okay. My exponent is 2. My number is 4x minus 7. So you can, I just like to put my number on the left side because I know I'm solving. But your number is your base to the exponent. Then you go ahead and go from there. Had I done this incorrectly, if I got my number, my exponent mixed up or whatever, I wouldn't have anything I could put in my calculator on the right side. So you should end up with an equation you can solve. Add 7, divide by 4. I believe that's right. And so I've solved for x. In part B, again, my base is 3. My exponent, and where people mess up at, they say their exponent is 2 to the x. Remember, your exponent's on the right side of the equal sign in a logarithm. Okay, so if you get these backwards, then you're done. So try to remember what's what here. My number is 2x. And you're saying, well, that's not a number. Yeah, it is. It's a number. We just don't know what it is yet. So I set it up. My number is my base to the exponent. Put 3 to the 2.5 power in your calculator. And I get 15.59 divided by 2. And I get about 7.8. Okay. So it's just a matter of doing this correctly. Again, see, there's not many steps here. This will be one of the fewest stepped equations y'all are going to solve. Think about some of the stuff we've solved in the past. 1, 2, 3 steps. This next one now, we've got a different logarithm, which means my base is e. My exponent is 3.2, and my number is x. So I change it to an exponential equation. So x is e to the 3.2. So that's one step. Second step is putting it into your calculator. And x is 24.5. So again, that's a two-step equation. That's why it's very important that you understand how to change from one form to the other. Okay. All right. Solving exponential equations. First, when we're solving an exponential equation, we have to isolate the base to the exponent. Make sure we have base to the exponent, and we have to know our number. Then we change to a logarithm and then solve. Now, we're going to get to other bases as we move on into 6.6, but for right now, we're just going to look at solving exponential equations with the base e. So think about your steps. The base to the exponent is isolated. I want to rewrite as a logarithm. So in this case, I do natural log. You're going back to exactly what we did here. Okay, exactly what we did here. So you can write ln of 5 is 2x. You can do 2x is natural log of 5. It doesn't really matter. I always just like to have my variable on the left side. So then I figure out, well, what is the natural log of 5? And it's 1.61. Divide by 2. And x is about 0.81. Okay? Depends how we round. So again, not many steps. Really, one step, divide by 2, 2 steps. Okay? Now, this next one. My base is e. My exponent is x plus 1. My number is 10, but, I got this 3 here. So before I can say what my number is, I've got to isolate my base to the exponent. So e to the x plus 1 is 3.33. 10 divided by 3. Now, my base is e. My exponent is x plus 1. And my number is 3.33. So it's a little different than up here. So as a logarithm, remember, as a logarithm, my natural log of my number is the exponent. Say that to yourself 1,000 times. The logarithm of a number is the exponent. And if you identify them and know how to say it, you'll know how to write it. Put that in my calculator. 1.2 is x plus 1. Don't forget your simple solving steps now. Subtract 1 to get x is 0.2. Okay? So we'll do more practice on this. But you just need to get a handle on what's what and how to change from one form to the other. Now, if I want to find the exact value of a logarithm without using a calculator, well, just remember that this is my base, this is my number, and I don't know my exponent. So I write it like that. Well, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, so I don't need a calculator because I can pretty much figure that out. Same thing with the next one. Again, 3 is my base, 127 is my number. I don't know my exponent. And since it's 1 over 27, then we have to have a negative exponent. And in this case, it would be negative 3, because 3 to the 3rd is 27. 3 to the negative 3 is 1 over 3 cubed, which is 1 over 27. So that's how I got that. Okay, so that's something, just in case you come across it, but I will show you all how to do these on your calculator when we cover 6.5. Next thing is the D word, the domain. When you think about a logarithm, we cannot take the log of a negative number. Our base is positive. So therefore, there's no way that you can take any positive base to a positive or negative power to equal a negative number. So in other words, if I want to take the log of negative 50, I get an error. Okay? If I want to take the log of 0, I get an error. So we know for our domain, whatever's inside these parentheses must be greater than 0. So given a function now, for my domain, x plus 3 must be greater than 0. So x has to be bigger than negative 3. Because if it's negative in here, I don't care what the base is, I'm going to get an error on my calculator. With this one here in part B, I know x minus 4 must be greater than 0. So therefore, x has to be greater than 4. All right, so that's domain, and we're going to also use the domain to help us graph. Okay, so here is your basic shape of a logarithmic function, a graph. Okay, you can't see it here, but this is, it's got a vertical asymptote. It's got an x-intercept. So the exponential function had a y-intercept. The logarithmic function has an x-intercept and a vertical asymptote because they're inverses of each other. Think about that the logarithm is the inverse of the exponential. And so we're going to shift again these graphs. So as you can see, if I put values into my calculator just with log x, it's a 0 for my x. When x is 1, y is 0. And I'm just getting really, really small numbers. I'd have to go all the way for x to be 100 just to get a y of 2. That's why this graph grows very, very slowly. Exponentials grow very, very rapidly. Logarithms grow very, very slowly. So in order to graph a logarithm, we first find the domain. Then we figure out the equation for the vertical asymptote. Find the x-intercept and sketch the graph. Okay, so again, think about this one here. My domain for the logarithmic function that's just log x is x is greater than 0. So therefore, my vertical asymptote is right here. My x-intercept is generally 1 point bigger, and make the sketch. Okay, so we can shift them. We can just find the 2 points, however it works for you. So when you look at the log of x minus 3, my domain is x is greater than 3. So when x equals 3, that's my vertical asymptote. When x is 4, well, f of 4 is log of 4 minus 3, which is log 1. Put log 1 into your calculator, and you get 0. So I plot it, and then I draw it, knowing that my graph does not cross over the vertical asymptote. You can also look at this as a horizontal shift right 3 units, and that's what we did. We shifted the vertical asymptote. We shifted the x-intercept. X-intercept was here, 1, 2, 3. Shifted the vertical asymptote. So either way of graphing is fine. Some people like points. Some people like shifting. So if I look at this one here, natural log of x plus 2, again, my domain, don't forget now, x plus 2 is greater than 0, so x is greater than negative 2. So when x is negative 2, that's my vertical asymptote. And again, it's a horizontal shift left. So I shift everything to the left. Which means if I find 1 point to the right, or again, shift my x-intercept left, is natural log of negative 1 plus 2. So natural log 1, which is 0. Plot it and sketch it. Okay, and again, this kind of borders that. Doesn't cross over. Okay, so that's graphing. We'll pick up with this in class, do some more examples of everything. It's a lot of stuff, so hopefully you're watching it. And obviously, if you're hearing me, you're watching it. So we will see you in class.